Welcome! Today we're diving into generalization. It's a fundamental concept that explains how a skill we learn in one specific situation can become useful across many different parts of our lives. Honestly, without it, learning would be incredibly slow and inefficient. So let's get into how it all works. So, let's start with a question you've probably wondered about before. You see a child learn a very specific word for a very specific person. But then, all of a sudden, that same word starts being used for new people, often in pretty funny situations. This right here is a perfect example of learning spreading beyond its original boundaries.
And then, there's this other side of the coin. Think about this. Someone is taught just one way to greet people, let's say by saying hello, but over time, they start using different actions, like waving or a fist bump, to accomplish the very same goal, even though nobody ever explicitly taught them to do that. These two scenarios might seem different, but they're deeply connected, and today we're going to unpack exactly how.
Both of those examples we just talked about fall under the umbrella of what's known in behavior analysis as generalized behavior change. It's really just the technical term for how learning naturally expands beyond the exact moment and conditions where it was first taught.
And this is so important. The key idea here is that generalization is what makes any learned skill actually functional. You can think of it as the bridge that connects a specific trained skill to the complexities of the real world. It allows us to adapt and apply what we know without having to learn every single possible variation from scratch.
Okay, let's dig into our first type of generalization. This one directly answers our first question, the one about the child calling different men daddy. This is called stimulus generalization. Let's look closely at this definition. A single, learned response, in this case saying daddy, is now being triggered by new stimuli, which are other men who just happen to share similar features, like having a beard. The child has generalized that label from the original stimulus to other similar ones. So to break it down, with stimulus generalization, the main thing that's changing is the stimulus. That's the trigger in the environment. The behavior itself, or the response, stays exactly the same. And this happens because the new stimulus is similar in some way to the original one.
This is a really clear illustration. The behavior, saying the word cat, doesn't change. What's changing are the stimuli that trigger that word. It generalizes from a photo of a real cat to a toy cat, and then even to a cartoon cat. The child has learned the core features of cat and now recognizes them in different forms.
All right, let's move on to the second type. This is going to complete the picture for us. This one's called response generalization, and it's the key to understanding our second puzzle about the different ways of greeting someone. Now notice the flip here. The key part of this definition is that the person starts using untrained responses. They're essentially developing new behaviors that accomplish the same exact goal as the original behavior they were taught.
So, if we look at the key features, they are basically the mirror opposite of what we just discussed. In this case, the stimulus, or the situation, stays the same, but the response, or the behavior, is what changes. And the most important part is that all of these new behaviors serve the same function. They all lead to the same outcome.
This is a great practical example. The situation, the stimulus, is that the student needs a break. They were taught one specific response, saying the words. But over time, they generalized to a new response that's functionally equivalent, pointing to a card. Both behaviors get the job done.
Okay, so we've covered two distinct types of generalization. Let's put them right next to each other to make the difference between them perfectly clear.
This table really boils it all down. With stimulus generalization, the behavior is the constant. It stays the same, while the stimuli are different. With response generalization, the stimulus is the constant. It stays the same, while the behaviors or responses are different.
For those of you in the field, here's a really useful mnemonic. BX is shorthand for behavior, and SD is the technical term for the discriminative stimulus. You could just think of it as the trigger. So for stimulus generalization, it's the same behavior, similar stimuli. For response generalization, it's different behaviors, same stimulus.
And here's a much simpler way to think about response generalization that I find really helpful. New tricks, same treats. It just perfectly captures it, right? You're using different behaviors, the new tricks, to get the same reinforcing outcome, the same treats.
You know, this pizza analogy brings it all home. Stimulus generalization is like performing the same action, ordering a pizza, but in different similar places, like from various pizzerias. Response generalization is when the stimulus is the same, you want pizza, but you use different behaviors to get it, like calling on the phone, using an app, or just walking into the shop.
So, why does all of this matter so much? Well, because if our goal is to teach skills that are actually useful in everyday life, we have to actively plan for generalization to occur. We can't just assume it's going to happen on its own.
Now, here are 3 proven strategies for making that happen. First, teach enough examples. You want to expose the learner to lots of different variations so they grasp the core concept, not just one rigid example. Second, program common stimuli. This means using materials and cues during training that they'll actually encounter out in the world. And finally, teach loosely. This means intentionally varying the little details that aren't critical to the skill, which helps the learner focus only on what truly matters.
All right, let's quickly recap the main points. Generalization is the essential process that makes learning stick and become truly useful. Remember, stimulus generalization means the same behavior occurs across new, similar situations. And response generalization means new behaviors emerge to fit the same situation. Understanding this difference is absolutely crucial for effective teaching. So I'll leave you with this final thought. Whether you're learning to use a new app or trying a new skill at work, both stimulus and response generalization are happening all the time. Now that you know what to look for, where do you see these processes shaping your own learning every day?